On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we're going to look at the mean value theorem, and the formula for the mean value theorem is something remotely similar to this. F prime of C equals f of B minus f of A all over B minus A. And we want to find some C value on a closed interval A to B that satisfies the mean value theorem. Here's our function, here's our interval. So automatically, let's go ahead and identify what A is equal to and B is equal to. Now, visually, what does this look like? So here we are inside of Desmos, and I have that same f of x graphed right here, and I'm going to take this interval. We were between 1 and 3. That was our A and our B value. If I restrict this function to this particular domain where this function's only defined between values of x between 1 and 3, this is what our curve looks like. Now, if I take this away, notice the curve comes right back, but if I put that restriction on the domain, it only restricts this part of the curve. This is all we can see here. What we want to do is we want to find the slope from this endpoint to this endpoint. That's the slope from f of 1 to f of 3. What is the slope of the line that connects those two endpoints? That's what this is really asking you to do right here. F of B minus f of A over B minus A. It's no different than y2 minus y1 over x2 minus x1. We want to find the slope of the line that connects those two endpoints. Then we want to find the derivative, and we want to find C. There is some number between 1 and 3. This is x value of 1 right here, and this x value of 3 right here. There is some number x between 1 and 3 such that the derivative at that value is going to be equal to this slope right here. So visualize this slope here, and probably somewhere right around in here, I'm guessing, is where we're going to have that C value, somewhere pretty close to 2. But again, I'm just visually looking at this. So again, imagine a line going here, and then some other line that's going to be parallel, but really all we're trying to do is find the value of C somewhere between 1 and 3 that has the derivative that's equal to the slope of the secant line. Let's go ahead and have a look at that. So let's go ahead and find the derivative. F prime of x is equal to negative 2x plus 5. Now we can go ahead and write this as f prime of c is equal to negative 2c plus 5. No difference there. I'm just matching up with the mean value theorem. Now let's find f of b and f of a. So f of b, that's f of 3. Let's plug 3 into the original function f. That's going to be negative 9 plus 15, that's going to give us 6, minus 1 gives us 5. Let's find f of a now. That's going to be f of 1. F of 1, well, that's going to be negative 1 plus 5. That gives us 4. 4 minus 1 gives us 3. And if we look back over in Desmos 2, f of 3 is equal to 5. F of 1 is equal to 3. So now we can come over to this side of our mean value theorem, f of b minus f of a. Well, therefore we can take f of 3 minus f of 1. That's 5 minus 3. So 5 minus 3, that gives us 2. I'll go ahead and write that down. Over b minus a. b is 3, a is 1, so 3 minus 1, that also gives us 2. So therefore the slope of the line that connects those two endpoints, the slope of that line is actually 1. Here's that same curve. I've zoomed in a little bit, but each little line that you see now represents one unit. Notice 1, 2, 3, and then we have like 2, 3, 4, 5. So if we go from here to here, we should have a slope of 1. Up 1, right 1, up 1, right 1. Notice that is the slope of the line that connects these two endpoints. So now back to the mean value theorem, f of b minus f of a over b minus a. We computed that here and got 1. We want to set that equal to f prime of c, which is what we found right here. So let's take f prime of c, negative 2c plus 5. Let's set that equal to f of b minus f of a over b minus a, which is 1. And let's solve this equation. Subtracting 5 from both sides, we get negative 2c is equal to negative 4. And then we divide both sides by negative 2, so our c value is 2. This was a lucky guess for this particular problem. Recall earlier I did mention it would be somewhere around 2 where the slope of that tangent line would be equal to the slope of the secant line. So looking here once again, we said the slope of this secant line right here would be equal to 1, and it turns out if we were to find the equation of a tangent line right here when x is equal to 2, the slope of that tangent line there is going to be equal to the slope of this secant line. And that's exactly what the mean value theorem guarantees. Now, one big thing that has to exist here for this to work is that your function must be continuous from A to B. So we've got to have a continuous function, and it's got to be differentiable over this entire interval as well. Well, we have a parabola. Parabolas are continuous everywhere, and they are differentiable through their entire domain. So we have nothing to worry about there. But the main idea about the mean value theorem is this. You want to find the slope of the line that connects your two endpoints. That's the slope of the secant line. You want to set that equal to the function's derivative, and you want to solve for that value of x. In this case, we called it c. And you should find at least one number. Sometimes you may have more, but you should find at least one number on that interval, in this case from 1 to 3, such that the derivative at that point is equal to the slope of the secant line. And there you have it. That's one example that covers the mean value theorem where we use a quadratic. We will explore other types of functions soon, but this is an introductory example. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.